So this is what we did last time. When you apply the limits, this becomes infinity, that becomes infinity. We ended up getting infinity minus infinity. Do I have the correct problem? Okay. We use the calculator, and when we use the calculator, it didn't look like it went to infinity. Right. So let's see earlier. So how do we get rid of the infinity part? Well, you could do the conjugate. What is the conjugate of square root of 16x squared plus x minus 4x? What is the conjugate of this term? There was an example problem on this. Everyone is intent on breaking my heart today. Can't take it anymore. Right.
Yeah.
The conjugate of this term is that term. So go ahead and multiply those two and tell me what you get. So a minus b times a plus b, that is an identity. What is a minus b times a plus b? I am sure we've been over this before. So a here is square root of 16x squared plus x. So limit x approaches infinity, square root of 16x squared plus x. That is a, and square minus b is 4x, and you square b. Divided by square root of 16x squared plus x plus 4x. So far, so good, yes? Now, what had happened to the root and the square? It will go away. So limit x approaches infinity, 16x squared plus x minus, what is 4x squared? 16x squared, x squared. Those two will get cancelled, yes. And we will end up having x divided by square root of 16x squared plus x plus 4x. Good. I want you to take infinity. So numerator, it would be infinity. What about the denominator? Infinity, infinity, infinity. So what is the answer? What? 1.
No.
No. It's not one, it's not undefined. So infinity minus infinity, infinity over infinity, these are called indeterminate forms. And they come into play when you take limits. Typically, I don't have time in this class to go over that. I believe it's section 4.6. Hopefully, if I have time this semester, I'll cover it. So that's an indeterminate form. That's an indeterminate form. Another one is 0 divided by 0. That's not one either. So the answer has to be something else. We know it is something else from last time, right? We graphed it, we had a different value. So I have 16x squared here, correct? If I pull 16x squared out of the root, what would I get? 4x. So 4x. I took out 16x squared, so that would just be 1 plus x over 16x squared. Yes? Plus 4x. You see where I'm going with this? Yes. So I pulled 16x squared out. So that term becomes 1, and I'd have x over 16x squared. What do we see in common between this term and that term? 4x. X squared, I could cancel. I will have 1 over 16x plus 1. Good. What would happen to this x and that x? Will get cancelled. With me so far. And that would equal to limit x approaches infinity 1 divided by 4. That's what we would have. Good. Now I can apply the limit. As x approaches infinity, would it affect the numerator? No, it will stay as 1. Would it affect the 4? No. Would it affect that 1?
No.
No. What about that term? It is going to affect that term because there is an x, but what would happen to its value? It'll get smaller and smaller because you have 1 divided by an extremely large number. X is approaching infinity, so that term has to go to 0. So in limit, that is 0. Square root of 1 is 1. So 4 times 1 plus 1, 2. The answer is 1 over 8. What type of function do we have here? Exponential. Now, if you simplify this, it is going to end up being a hyperbolic trigonometric function or a hyperbolic function. We won't get into that. So, if you apply the limit, what would happen to e raised 3x if x gets larger and larger and larger? It's an exponential function, and if x gets larger and larger and larger, that would become large, right? So you have infinity. that is an exponential decay function. So if x gets larger and larger and larger, what would happen to that term? It'll get smaller and smaller. So that will become 0. Good. Same argument, as x gets larger and larger, e raised 3x would approach infinity. E raised negative 3x would approach 0. Infinity over infinity, the answer is 1. Paying attention, good. It's not 1. I'm glad everyone made a face. So it is not 1. Infinity over infinity is not 1 when you take limits. It's an indeterminate form. Yes.
So we're doing infinite limits. The first thing that we should do is go over to each of the cases and look at the most extreme thing that we can.
Yes.
And again,
So there has to be a trick that we need to do in order to get to the correct limit. So what I'm going to do is to pull e raised 3x out. So that would become 1 minus e raised minus 3x divided by e raised 3x. Good. I can do the same thing with the denominator. Going to pull e raised 3x out. 1 plus e raised minus 3x divided by e raised plus 3x. Good. What would happen to those two? Get cancelled. I can combine this and write it as a single term. Properties of exponents. What will that reduce to? Bases are identical. What do you do to the powers? You subtract them. So e raised minus 3x minus 3x. Get minus 6x. Divided by 1 plus e raised minus 3x over positive 3x. So minus minus, you get e raised minus 6x.
1 minus 3x over e to the power of 3x here.
X approaches infinity, and that is a decay function. So if x gets larger and larger and larger, what would happen to that function? It's going to get smaller and smaller and smaller because it's decay. What about that? The same. So when we take the limit, that would go to 0. That would go to 0. So the answer is 1.
Then we end up
if we have ln of A plus ln of B, that is equal to ln of A multiplied by B. If we have ln of A minus ln of B, that would be ln of A divided by B. As I went around, so if you did this partially, remembered, but you wrote it this way, that is incorrect. There should be 1 N. And someone else did this. If life was that easy, right? You can't cancel out independent. Okay, so ln of A minus ln of B. I've combined the two. How do I take the limit? one of the limit laws. If you have a function and we are taking the limits, we can move the limits inside the function. Correct. So I can move that in.
Thank you.
What would we get when we apply the limit? So if you look at this function that is inside, that is a rational function, correct? You have a polynomial divided by polynomial. What is the degree of the polynomial? 1. Are they equal? Yes. So if the degrees of the polynomial are equal, and we are taking x approaches infinity, what would the horizontal asymptote be? We went over this last time. 0, 2,
Yeah.
0, 2, 1, 2. Guys, it makes me want to live another day. It's x plus 2 over x plus 1, right? And limit x approaches infinity. Now, what would it approach to? Huh?
It'll be like 1/1.
It's 1 over 1, right? So we take that coefficient, and we divide. Get the degrees are equal. So we will have ln of 1. What is ln of 1? 0. Okay, so if you have a polynomial of a polynomial and the degrees match, all we have to do is to divide their coefficients. That's it. That will be the horizontal asymptote. What is the rationale behind it? If I pull x out, I will get 1 plus 1 over 2x. If I pull x out from the denominator, I will get 1 plus 1 over x. The x's will get cancelled. If x approaches infinity, you are dividing by number 2 by a number that's getting larger and larger and larger. So that will approach to what value? 0. How about that one? 0. 1 plus 0 over 1 plus 0, you will get 1. If I change that to 3 and 2, the only difference would be that will change to 3 and that will change to 2. The answer will become 3. Yes.
Okay, so last month, you said that it's a possibility to have an oblique asymptote. How come in that case it's not?
It is possible to have what?
An oblique asymptote.
An oblique asymptote will only happen if the numerator degree is exactly 1 more than the denominator. So this would be x squared, and that has to be x. So this is a function, and we can take the limit directly inside. So tangent inverse limit x approaches infinity, e raised to x. Yes. What happens to e raised to x as x approaches infinity? It becomes, or it goes toward
1.5.
later, but inside, when x approaches infinity, what happens to exponential? It's a growth function. Infinity. So you would have tangent inverse of infinity. This would happen at the value of pi over 2, which is 1.57, if approximately. If you look at the graph will start climbing and eventually it will plateau at that value of 1.57. Good, yes.
Like, how you know it's 1 point? like 2 or 7, or like how do you know that?
3.14/2. That's fine.
You do second and then.
Pi is 3.1415926535. You're a math student. Aren't you a nerd?
What?
Aren't you a nerd?
Yeah.
Wait,
I
you don't know why it's 1.
No, I know why it's 1.57, I just don't know like why it's pi.
Oh, tangent inverse of infinity is always pi/2.
Oh.
You know, the unit circle thing. Yeah, it's circle.
Wait, why is
We've been
it?
over that too.
Why exactly is it pi/2? I know you said about the unit circle.
Sine pi/2 over cosine pi/2, right? Yes, and that would be equal to tangent pi/2.
Oh, I see, my apologies.
So the denominator would become 0 as pi/2, so that would end up being pi/2. Okay. Question?
Yeah, kind of.
So, what is the tangent?
You're going to use the property of the very least.
Property of logarithms. So ln of 3 plus 2x squared divided by 1 plus x. And most of you did well in recognizing that this is an oblique asymptote if you move that limit inside. Excuse me, it will have an oblique asymptote. And why is that so? Because the numerator degree is exactly 1 more than the denominator. As I mentioned, an oblique asymptote is simply an asymptote that goes at an angle. So, but it still is going toward infinity. So when you take this limit, that would become infinity. And that logarithm of infinity is infinity. Good. To kind of get the answer by looking at the graph. Most of you got the graph, but I went over. One calculator had 1.32, another one had 1.27 negative, and then there was negative 1.48. None of them are exact answers. The exact answer is negative 1.57. Where did we see that? We saw that in the other problem, it was pi/2, right? So as Alejandro asked me earlier, well, why are we looking at a limit that is approaching toward infinity? It is because of the fact that as x approaches 0, the function that is inside the tangent will approach infinity. So at the end of the day, I'm looking for an infinite limit. Good. So
it would be pi/2 at the very least, or some form of pi/2.
what is some form of pi/2?
No, I mean either negative or positive pi/2.
Okay, I see. So we can move this inside. So we would have limit x approaches 0 plus natural logarithm of x. Correct? So if you look at the graph, probably looks like that. And that point is what we need to find. And as I mentioned, some got negative 1.4, some got negative 1.2. But we know the exact answer. As you approach from the right-hand side, you can move the limit all the way to x. So we know the graph of a natural logarithm. What does that look like?
So both of them are going to end up being equal to around pi/2 or negative.
No, what does the graph of natural logarithm look like?
Oh, I'm sorry. or something out loud.
So 0 is right here. As you approach natural logarithm, excuse me, x from the right towards 0, what is happening to the natural logarithm function? It is going toward negative infinity in limit. Yes. So the limit of natural logarithm is negative infinity. So we've got an infinite limit. So we are in the right chapter. Tangent is an odd function. Tangent inverse is an odd function. So tangent inverse of a negative value would be equal to negative of whatever value you have. So negative tangent inverse of infinity. We did that earlier today. That is pi over 2. So the answer is negative pi over 2. In your calculator, the answers that you got would be closer to negative 1.57. The reason why you're just getting different answers is because of the fact your scales are different on the calculator. Depending on how precise your scale is, the answer is likely to vary. But at the end of the day, you should get an answer that is close to negative pi over 2, which is negative 1.57. Great. When I approach 0 from the left, what is the limit? This is our function, tangent inverse of ln of x. When I approach 0 from the left, where is the function going? I know you guys are hungry, I am too, but when you come from the left, where does the curve go to? Left towards 0.
It doesn't exist.
Doesn't exist, there is nothing here. I don't know what you guys are seeing. I don't see anything. So there is nothing here, so it doesn't exist. So we know when we come from the right hand side, it is negative pi over 2. There is nothing here for the function to go to, and that happens because of logarithm. There is nothing here. So I don't know where you're going on this side. Good luck. So that limit doesn't match that limit. Does the limit exist? No.
I thought the whole point at the very least of us going in, at the very least, the lines of infinite limits and such